Hey guys, it's Lexi, and in this video I'll be giving you a flowchart to easily be able to determine if a molecule is aromatic, anti-aromatic, or non-aromatic. I'm going to give you guys some examples of how to use this flowchart to determine if a molecule is aromatic, anti-aromatic, or non-aromatic. First, let's review localized and delocalized electron pairs. A localized electron pair is referring to a lone pair that cannot move via resonance. So for example, if you look at this nitrogen atom, it already has a double bond. And so that tells you that the lone pair that's on top of this nitrogen cannot participate in resonance because the p orbital is already occupied by this double bond. However, if we look at this nitrogen, it has a lone pair as well. And this lone pair is allylic, meaning it is a single bond away from a double bond. And the nitrogen does not already have a double bond. So that tells us that this lone pair can participate in resonance. And so this lone pair is said to be delocalized. Let's try this example. The first question, is it a ring? Clearly the answer here would be yes. Then when it asks, is it conjugated? That refers to every atom of the ring being sp2 hybridized. If we look at all of these carbons, we can see that they're all going to be sp2 hybridized. And if you're having trouble determining hybridization, I do have a video on how to determine hybridization because it is really important to understand hybridization before you can determine aromaticity. So in this case, all of these carbons are sp2 hybridized, so we would answer yes, this is conjugated. When I ask odd or even, I'm referring to the number of pi bonds and the number of delocalized electron pairs. Well, in this case, there are no electron pairs, but we do have pi bonds. We have 3 of them. So this would be odd. And so this molecule is therefore aromatic. Let's look at another example. So the first question, is it a ring? The answer is obviously yes. Is it conjugated refers to every atom of the ring being sp2 hybridized. So if we go around the ring, we see that this is sp2, sp2, sp2. And then if you look at the nitrogen atom, it has a lone pair. And that lone pair is localized. And the way that we know that is because the nitrogen is already part of a double bond, meaning that the p orbital is already filled. So when we're doing hybridization of this nitrogen, we are going to count the lone pair. Because remember, for hybridization, you only count localized lone pairs. So this is going to be 1, 2, 3, sp2. Then you've got this carbon that's sp2, and this carbon's also sp2. So the answer is yes, this is conjugated. Odd or even, we are going to count pi bonds within the ring, and then we're also going to count delocalized lone pairs. So in this case, we have 1, 2, 3. We're not counting the lone pair because it's localized. So this would be odd. And we can conclude that this molecule is aromatic. Here's another example. So the first question, is it a ring? The answer would be yes. Is it conjugated? So we're looking to see this is sp2, 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 and sp2. And then over here we have a carbocation. Remember, a carbocation is a positively charged carbon atom, which is a carbon with only 3 bonds and no lone pairs. So this would be sp2 as well. And so we can conclude that this is conjugated. And so we'll go yes, odd or even. So we've got 1, 2. There are no lone pairs, so 2 is even. And so does it have at least 7 members in the ring? And if we count, here we have a 5-membered ring, so the answer is no, and this molecule is anti-aromatic. Here's another. So first, is it a ring? The answer would be yes. Is it conjugated? We're going to go around. This is sp2, 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 and sp2. If we look at the oxygen atom, it has 2 lone pairs. So when you have a situation where an atom has 2 lone pairs, only one of them can possibly be delocalized. You can't have both of them be delocalized. It's possible that they're both localized, but you can never have both of them be delocalized. And so if we look at one of these lone pairs, either one of them, you'll see that they're allylic to the double bonds. And what that means is that the lone pair is a single bond away from the double bond. So it's allylic. And so we can say that one of these lone pairs is delocalized, meaning it can participate in resonance. Then the other lone pair is going to be localized. So we're only going to count the localized lone pair when we're doing hybridization. So this would have 1, 2, 3 electron groups, or it would be sp2 hybridized. So we can say that yes, this is conjugated. For odd or even, we're going to count the pi bonds within the ring as well as the delocalized electron pairs. So we have 1, 2, 3. So this is odd, and we can conclude this molecule is aromatic. Here's another example. So first, is it a ring? This is yes. Is it conjugated? So we're checking if every atom is sp2 hybridized. So here we have sp2 all the way around the ring. So the answer would be yes. Odd or even, we're going to count the number of pi bonds in the ring as well as delocalized lone pairs in the ring. So there are no lone pairs here, but we do have 1, 2, 3, 4 pi bonds. So that's going to be even. Next question, are there at least 7 members on the ring? So how many atoms do we have on the ring? This ring has 8. So the answer here is going to be yes. And we can conclude that this molecule is non-aromatic. So here's another. Is it a ring? The answer would be yes. Is it conjugated? We're going to check if every atom in the ring is sp2 hybridized. So this carbon and this carbon are, as well as these two. However, if we look at this carbon here, we know that it has 2 hydrogens attached, and then it's also bonded to these 2 carbons. So that's going to be 4 groups around it, which is sp3 hybridized. Because this carbon is sp3 hybridized, we cannot call the ring conjugated. So the answer would be no, and this molecule is non-aromatic. Here's a problem for you to try. Go ahead and pause the video and then you can check your work. First question, is it a ring? We know that that's yes. Is it conjugated? So we have to check if every atom in the ring is sp2 hybridized. If we start, we see this carbon is sp2, this one's sp2. If we look at the nitrogen, it has a lone pair. The nitrogen, however, already has a double bond. So we know that the p orbital is already occupied. That means that this lone pair must be localized. If we look at the number of groups around the nitrogen for hybridization, it would be 1, 2, 3. So this is sp2 hybridized. Carbon here is sp2. If we look at this nitrogen, it also has a lone pair. However, this nitrogen does not already have a double bond, and the lone pair is allylic to these 2 double bonds, meaning the lone pair is a single bond away from the double bond. And so we can conclude that this lone pair can participate in resonance. So the lone pair is delocalized. So we're not going to count that lone pair when we're doing hybridization. So for the hybridization of the nitrogen, it would be 1, 2, 3 sp2. And then we have concluded that every atom in this ring is sp2 hybridized. So is it conjugated? Yes. Odd or even? For odd and even, we're looking at the number of pi bonds in the ring and also delocalized lone pairs in the ring as well. So we have 1, 2 pi bonds, and then we also have this delocalized lone pair. So it's going to be 1, 2, 3, which is odd. And so we can conclude this molecule is aromatic. Thanks for watching. If you have any questions, feel free to leave them in the comments below. If you enjoyed the video, make sure to give it a thumbs up, subscribe, and also hit the notification bell so that you can stay up to date when I upload new videos.